ChipTalks podcast. It's another exciting Friday. We're coming to you from our secret underground, it's actually above ground, and not too secret, bunker location right outside Ada, Oklahoma, Ada, America. So if you're in the neighborhood, come by and see us. We would welcome audience members for ChipTalks. We haven't had anybody yet, but you're more than welcome to come in and stop in if you want to watch us do an exciting version of ChipTalks. So today I've got some really good stuff to talk to you guys about. I want to talk to you about mitochondrial health, and I want to talk to you about what we can do to improve mitochondrial health. Now, one of the things, as you guys know, I'm a U.S. patent holder in how to improve your life in herbal supplements. I actually hold the first issued U.S. patent on being able to manipulate something called the endocannabinoid system with non-cannabis plants. So again, I usually talk a lot about the stuff that I create and I invent in my own products. Today I'm going to talk about some other products. I am still going to talk about one that I invented called Focus. But I'm also going to talk about this LifeWave product, and there's a reason for that, but I want to walk you through the science. And one of the things that I found is that I can, if you have something going on with you, I can help you quite a bit. And I can help you understand how to work your immune system, and I can give you supplements that are going to supplement your immune system. But there's still this kind of electricity thing or power thing, or but it's hard to describe, but like this hurdle, that I see in a lot of people. So a lot of people we help just what we do. Some people are stuck and we can't quite get them over this hurdle. And I think that part of what that is it's an energetic thing that I'll hopefully be able to explain through the course of this. It's really not documented anywhere, but I think I can walk you guys through this and help you understand kind of what I'm seeing in ways that we might break the log jam, let's say. Okay, so first of all, I got to lay some groundwork on how you work and give you some understanding about your function. So we're going to talk about mitochondria today. And I've talked about mitochondria before. I've actually made the claim that I think that the mitochondria are your philosopher's stone. I think they're literally the key to understanding almost everything. If you understand how those guys work and you understand about them, that's how important I think that they are. But mitochondria are really important because they are the source of our energy. So if I stopped all of your mitochondria from working, you would be dead. Okay, you would be dead. If I stopped all your mitochondria from working, you couldn't create a thought. If I stopped the mitochondria working in your heart wouldn't beat. If I stopped the mitochondria working in your fat, you would get very, very cold. You wouldn't be able to maintain 98.6 degrees, okay? So mitochondria are everything. I mean, they're everything. They are, the little gem, the little sparkle, the little light, inside of us. And we've got tons of them, okay? So we're going to talk about them today, and we're going to talk about mitochondrial health. Now, when I look at impacting mitochondrial health, I've got a way to do that. And we did that when we were targeting autism. So we went at mitochondrial health in order to look at autism and kind of what we could do at autism, because autism is thought to be a mitochondrial disease. It is a mitochondrial disease. And guess what? Targeting the mitochondria with supplements helps autistic people, okay? And so we have product there, we got lots of testimonials there, but we've been able to move the needle there. And there's a reason for that, and it's because of basically how important mitochondria are, okay? So we're gonna really talk about what can go wrong with a mitochondria, all right? And so what could go wrong with a mitochondria, because as we begin to understand what could go wrong with a mitochondria and sort of fix that problem, whoosh, all these other problems magically resolve themselves, okay? So what could go wrong with a mitochondria? Well, the biggest thing that, you could have signaling that would cause that mitochondria to be forced into an energy state. And mitochondria have 3 energy states. They will run on glucose. So let's say they'll build ATP from glucose. They'll build ATP from fat, which is 50 times more efficient, and they'll build ATP from light, which is even more efficient than that. Okay, so they're trying to build ATP, and so they're signaling things where they won't be able to signal, and that causes something called oxidative stress. There's also things where they might not get all their intermediaries, and again, that causes something called oxidative stress. So really the main ways that mitochondria dysfunction are oxidative stress. So if we could solve the oxidative stress problem, we would solve a lot of mitochondrial problems, but thereby solving a lot of cellular problems, thereby making you more healthy, okay? So hopefully you guys are with me so far. It's really about the oxidative stress and getting those mitochondria to be as healthy as they can be. Now, if you look at how a mitochondria works, this is kind of cool. So what's the gas pedal in a mitochondria? What makes it go faster or slower? Turns out that's the endocannabinoid system, which is pretty cool. But what I want to do is I want to show you this graphic. And again, I want to kind of talk you through this graphic of basically things that cause oxidative stress, okay? So these are the things that a mitochondria will eventually sense and begin to have oxidative stress because of these. So if you're a cigarette smoker, you produce a lot of oxidative stress. If you're around a lot of environmental pollution, you're going to have oxidative stress. By the way, these are things that we can all mitigate. This is behavior and diet stuff, okay? Alcohol and drugs cause oxidative stress. Sometimes ethnicity and race, and it kind of depends on where you're located in the sun. So if you have a lot of melanin, let's say the darker you are, the further south you need to be. If you're further north, you will have oxidative stress just because of your skin color, okay? High fat diet causes oxidative stress. Malnutrition causes oxidative stress. Too much sugar causes oxidative stress. High BMI, so if you're overweight, if you're carrying too much body weight, that causes oxidative stress. Geographic location can cause oxidative stress. Stress can cause oxidative stress. And infection can cause oxidative stress. So again, these are the things that we here at Neighborly Nutrition are trying to educate you guys about and trying to get you to either change these behaviors, get rid of these behaviors, or we're trying to mitigate some of these behaviors. Why? Because it causes oxidative stress, okay? And oxidative stress, your body has a way to mitigate oxidative stress. So you can think of this as oxidative stress is happening, and you've got these things that'll come along and kind of mitigate oxidative stress. One of them is called glutathione, okay? So glutathione will mitigate oxidative stress. Vitamin C helps with oxidative stress, and vitamin E helps with oxidative stress. So you've got stuff to help you with oxidative stress. But again, let's say you've got a wicked bad bacterial infection, you smoke cigarettes, and you live over a lead mine. Again, you're going to lose that war, right? Unless we supplement you with something, unless we can help your mitochondria, unless we can help you offset all that crap and sort of be a stronger you. Okay? Makes sense? All right, so now I want to really talk about some things that would help mitochondrial efficiency, all right? And in particular, I want to talk about something called copper. And I want to talk about copper because, again, Linus Pauling, who is a two-time Nobel laureate, he won Nobel, I can't remember exactly what he won the prizes for, but vitamin C, if I recall. But anyway, he's one of the only two-time, if not the only, two-time Nobel laureate winner. Studied mitochondrial health, studied some things around mitochondrial health, but studied a lot about oxidative stress, right? And that's why he studied vitamin C. And he knew that mitigating oxidative stress would really help you. So if you're in a situation where you've got all this oxidative stress because of all this stuff that either you're doing or consuming or stuff around you, you got all this oxidative stress, it's going to suck up all your vitamin C, vitamin E, glutathione, and everything, at some point, right? So is there additional stuff that we can kind of throw in there to tip the balance where now your body's winning? Now you begin to damp it down. Now you've got enough juice and resources to begin to mitigate that oxidative stress. Well, it turns out copper is a pretty important thing in doing all this. And in fact, if you're copper deficient, you can't build antioxidants, glutathione, in the same way that you would. So copper is a super important thing, and I want to just read you some of these bullet points. I know you love it when I read to you, don't you? But I'll read to you some of these bullet points, and I'll discuss them as I'm reading them. But copper is an essential cofactor for oxidase enzymes. So that means any enzyme that's using oxygen, copper is going to be an important cofactor for. And why? It catalyzes the oxidation reduction reactions in various metabolic pathways. So oxidative stress is caused by improper oxidation reduction reactions in pathways. So this is saying that copper mitigates that. Copper is going to help you with that. Copper is going to help you mitigate oxidative stress. Super duper important, okay? Super important. These copper-dependent enzymes, or cuproenzymes, participate in, for example, energy, ATP, iron metabolism, connective tissue formation, and neurotransmission. Some pretty important stuff, okay? Dietary copper insufficiency in humans has been infrequently described. It's not well characterized. We don't know a lot about it. We don't know a lot about what happens to you if you don't get enough copper. However, copper depletion may occur due to intestinal defects like bacterial infections and invasions, high supplemental zinc intake if you take too much zinc, or in genetic conditions such as Menkes disease. Intestinal copper absorption is severely impacted in Menkes disease, leading to systematic copper deficiency. So we know about it in Menkes disease, although it's just hard to quantify. Assessing copper status in humans is challenging. It's hard to quantify, since no definitive biomarkers exist for detecting moderate or subclinical copper deficiency. So I don't know if you have a copper deficiency or not. I don't have a way to measure that. So you might as well assume that you do. I'm assuming that I do. The development of more precise and sensitive biomarkers for copper nutritional status is thus a critical area for future research. Aspiring bright young minds, figure us out a copper test. Copper imbalances in humans increase risks of bone demineralization and osteoporosis, fatty liver disease mortality, and cardiovascular neurodegenerative diseases. In certain pathological diseases, dysregulation of copper homeostasis may not be a primary outcome, but could rather be a secondary to some aspects of disease pathogenesis. So what this is saying is there's some diseases that will eat up your copper. And we know this, again, because if you're doing all of this mitochondrial work that you kind of need these redox enzymes for, that copper is facilitating, you're going to have competition, okay? And again, that could hurt you depending on what you've got going on. Accurately assessing dietary copper intake is difficult since the copper content in many foods has not been firmly established. So it's hard to know if you eat organ meats how much copper you're really taking in. Copper toxicity is rare, meaning you really can't overdose or get too much of it. So copper is an essential trace element for humans and other mammals. I mean, that's just it. You need it, and you have to have it for the reasons that I just described, because you need it basically to move ions and electrons around. Put it this way, without copper, your mitochondria will not be able to move electrons and you would not be alive, okay? So it's not that kind of important to our function. Now I know copper is important. How do I get it in you? Well, we know that that you will absorb copper ions. So you will absorb copper as an electrical kind of output. So if you look at copper as a metal, copper's a metal. So this right here, my little pinky thingy, my deal. So this copper is always pulling in electrons, and there's always electrons moving around the copper, in and out, in and out, in and out. Some of these electrons that the copper is pulling in are going into me. That's why I'm aware, and they're going into me as copper ions. That's why I wear copper. And this is how I'm getting copper inside of me. Again, you can ingest copper, but it's, in organ meats and all kinds of food, but it's hard to know whether that's getting in you or not, all right? So orally, not such a good way. Topically, it's very well understood that you can get copper in you topically. And again, the copper beds, drinking out of copper, containers, things like that. That's why those things work, the copper bracelets, all that. So I know I can get copper in you topically. Now, copper itself, though, it's better if it has a chaperone or a carrier, okay? So if I can tick it to a fat or a protein, nanoparticle, then again, it's going to move through you better and it's going to move through you easier, all right? And it turns out that there is a peptide, and a peptide is just a string of amino acids. It's a protein that's 20 amino acids long, but it can be different amino acids long, let's say. But there is a peptide called GHK that is a very important peptide inside of us. That's a human repair peptide. That's also a really good copper chaperone. Okay. Lots of studies on GHK CU, so that's GHK, this peptide with a copper stuck to it, and its ability to impact human health, its ability to cue stem cells, its ability to regenerate tissue, its ability to do all this good stuff. Well, why? Again, it's dragging that copper around, and it's dragging that copper to mitochondria. And we already know if we can get the mitochondria to work better, you're going to work better. So a lot of reasons kind of why this GHK CU works. So I'm going to read to you from a really cool study. And I'm going to talk to you guys now about this peptide, about GHK CU and kind of what it can do. Because it's so cool and so exciting. So, my task is all about getting your immune system to activate, getting you to understand your immune system, understanding how I can bolster that power, understanding how I can get better genetic expression and all that, around your ability to defend yourself. Well, guess what, boys and girls? This is one bad A molecule, okay, and what it does. So I want to kind of talk you through some of this. And there'll be references to these studies that we'll put in, so if you're reading the description on the video, you'll be able to see basically descriptions of these studies. But I want to read this to you. So GHK is a human copper-binding peptide with biological actions that appear to counter age-associated diseases and conditions. GHK, which declines with age. Why do you age? Again, every single cell inside of you will regenerate. Well, is this the potential ticker? Is this the tick-tocker? So it declines with age. It has health-promoting effects on many tissues such as chondrocytes, liver cells, and human fibroblasts, improves wound healing and tissue regeneration, skin, hair follicles, stomach, and intestinal linings, bony tissues. Now, I can just tell you, just increasing your intestinal lining, that health of that tissue is just unbelievably beneficial to your health. Increases anti-pain and anti-anxiety effects, increases cellular stemness and secretion of tropic factors by mesenchymal stem cells. Studies using, so it's just this thing, really? It's like unicorn stuff, okay? Which is amazing, So this study talks about the genetic effects with GHK and kind of what happens inside of you. So this is a really, really good study. And again, we'll leave references to this study under the video. But let me just I want to talk to you about some of the genetic expressions that you can get with this molecule. And then I'll talk to you a little bit about how to get the molecule in you. So this is the first thing. And this is basically, in this study, what they did was they looked at genetic expression with only just this GHK CU stimulation. Now, I read a lot of studies. Again, I have never seen anything like this that causes this much genetic expression. But this is just for pain. And again, this study goes through all different aspects of physiological kind of effects. But this one in particular is for pain. And so let me really talk to you guys a little bit about what this does for pain. So right off the bat, you see that basically GHK is affecting the opiate receptor, all right? And, again, this isn't going to affect you like an opiate by any means, but it is affecting that opiate receptor that we know is so important for pain management. And in fact, it changes it by over 1,000%, by 12,000%. The other interesting thing about this, the pain, basically genetic changes that happen under this molecule, is it affects the CB1 neuroreceptor. And it causes the CB1 neuroreceptor to be expressed at about 172% level. So that's pretty important. And again, I look at stuff that will affect CB1 expression all the time, and it's you know, it's not easy to do. So just those two things right off are a pretty jaw-dropping result of what this guy can do. The other one is, this is just antioxidant activity. And again, antioxidants are gonna, if you have more oxidation, if you have more ROS, you know, volcanoes going off, ROS type reactive oxygen species, then you've got antioxidants, you're gonna be in trouble. You're gonna have tissue damage, you're going to have organ damage, you're gonna have organ failure, you're gonna have all kinds of stuff happening. And that is the pathology of most disease. Most of what I see happening right now can all go back to this ROS, reactive oxygen species, and too much, and not enough antioxidant activity. So what does this guy do for antioxidant activity? Well, he does a lot. And again, if you study this, and I don't want to get too scientific for you guys, but one of the biggest factors that you see in inflammation, and kind of a negative factor, let's say, I mean, it's important, we need it, but if it's overexpressed, it's really, really bad. And it's something called nuclear factor kappa beta. And it's a gene transcription that will overlay your DNA and cause you to do all this stuff that's very inflammatory. Well, guess what this molecule does? GHK CU right off. It's modifying that gene by 762%, okay? So, huge stuff. All right, so we have an effector, and we have a mitochondrial effector, which is great, this GHK CU product. We can put, so if you look at how that you would take this product, all right? Again, copper, it's not well characterized, as I started off with, how to get copper inside of you. GHK itself has some wound healing stuff, but with a copper chaperone, it sort of synergizes. So not only is it pulling copper inside of you, but it's also giving you GHK, which is good for healing and all kinds of stuff. So these two things together can get into the mitochondria and begin to help the mitochondria fight oxidative stress, reactive oxygen species, tamp that down. Now, you guys can satisfy yourself to the health benefits if we can get that going. But again, in my mind, you know, if I look at a very severe pathological disease, let's say you've got something like Epstein-Barr, or you've got something you're losing, a cancer or something, where you're losing the battle. I mean, it's winning. You know, we're supplementing you, we're trying to do all kinds of stuff, and you're not getting better, or you're getting better too slow. The reason for that is going to come back to mitochondria and likely reactive oxygen species. So, you know, if you don't have enough stuff to be able to mitigate the reactive oxygen species, you will not be able to win that battle. So we think this product by LifeWave, it's called X39, it's a patch, and the patch delivers GHK CU. And it delivers it in a very controlled way, and it delivers it, interestingly, through a photo reaction, which is just fascinating to me. So it's looking at certain wavelengths of light to be able to deliver this copper peptide. So I'm going to be looking at this a lot more. I've got one of these patches on now. I'm going to be putting these patches out. Some of you guys might be getting calls. Hey, do you want to try this patch? Certainly, I want to try it with you guys out there that we help that have more severe disease states, because we want to see if we can, you know, throw in that additional horsepower to give your body the additional juice it needs to fight some of this stuff off. And copper looks to be a big thing, and GHK looks to be a big thing. So I'm pretty excited about, you know, some of these situations where we've got folks that are kind of stuck or going too slow, where we might be able to, you know, push them over the edge. The other thing is, if you guys are interested in this as a business opportunity, there's a pretty significant business opportunity here. This is still early, and I'll tell you right now, just having reviewed the science, there's a lot to this. This is going to be something, and these, you know, it could be other copper peptides, but these guys have got it figured out pretty well, and they've got it figured out well enough to where I don't need to go duplicate it or redo it. And for me, that's saying a lot, right? So usually I'm looking at ways that I can improve on things, or do it different, or do it a little better, or add a nuance. And I don't know that I can do this better than what these guys are doing now. So this is a really cool product. Again, LifeWave, we'll leave some links in here if you're interested in it. But the big thing and the great news here is this copper peptide, being able to get it in you and all the magical stuff that we think it's going to be able to do and really help your body with. And the reason for it, all mitochondrial health. Anyway, we'll leave it there for today. Love you guys. Get healthy. Follow what we do because we're on it. We're going to bring you a whole new health paradigm. We already are. And we want to really help you on your health journey. We want to be your educator and we want to be, your product supplier, but we understand our products very well, vet our products. We would be bringing you something if we didn't think it was really, really good. Anyway, see you guys. See you next week for another exciting version of ChipTalks. Bye.